In this video I'm going to show nominal shear, and we're going to verify that the beams that we've selected in our previous videos, establishing the loads, MD solids, and nominal moments, we've ended up with a W12 by 14 beam that we're going to verify meets the shear requirements that we need. So the first step is figuring out what the shear requirements are, and then we'll double check to make sure that that beam's actually capable of doing it. So V is our variable for shear, N is nominal, and I like to do actual times my factor of safety. So my nominal shear that's required is equal to, from our MD solids activity, it was 9,000 pounds was our end reaction, or our shear reaction on the MD solids. And our factor of safety for shear is a little bit less than it was for our moments. And it can be less because the moments offer so much more strength or so much more problems when it comes to bending materials than shear. And shear is going to be a lot less, and so we don't need to worry about it quite as much as we do the moments. And you'll see why at the end of the activity. So once we do 9,000 times 1.5, that is 13,500 pounds. And this is the nominal moment that we have to meet. That's what the beam has to be capable of. And now we'll actually see what this W12 can do. So there's a little bit that we need to do for figuring out what that W12 by 14 is able to do. And the formula for that, and I always like to do this, W12 by 14. So the nominal shear for the W12 by 14 is equal to 0.6 times Fy times the area of the web. And the web of the beam, let me draw a quick I-beam over here. The web of this beam is this middle part that I'm going to highlight in green. This middle part right in through here is doing all the work, all the heavy lifting for shear. And so we're going to figure out how wide this green part is and how tall this I-beam is. And to do that, we're going to do a little bit of work and looking up information on a table. And so we'll go to this table over here. So we're going to find these dimensions on the table over here. And this is the table, once again, from that structuraldrafting.net or net.com. And the specific things that we're going to be looking for are the thickness of the web, which is right here, and the depth of that web, which is right here. So we're looking for 11.91 and 0.2 on this table. So go back over here, and my nominal moment is going to be equal to 0.6 times 50,000 pounds per inch squared times the height, which is 11.91, times the thickness of the web, which is 0.2, and both of these are in inches. So I'm going to have inch squared cancel out all the way across, and I'm going to be left with pounds. And that'll be the nominal moment that's required by this beam. So let me put that in my calculator, and I end up with the nominal moment for a W12 by 14 is equal to 71,460 pounds. So this is what the W12 by 14 is capable of. This is what our beam has to be able to do up here, that 13,500. So as long as the number that I end up down here ends up larger than my nominal moment up here, this beam is good. And it's good by a lot. You see that several thousand. It's capable of holding 71,000, needs to hold up 13.5. So this W12 by 14 still works for us. And so that's the one we're going to keep going with from this point forward.